All right, guys. So as we wrap up part one with kind of a part one video two, we're going to look into utilizing what we know about the derivative of a function a with a base a, random number a, to some particular variable that we've been dealing with. Okay, but I wanted to. The goals are the same. It's finding the derivative of the function of a random variable or a random base to a specific variable. But what we're going to look into today is a little more into the application of it and kind of take a little step back and just kind of always remind ourselves of what we are really finding when it comes to finding the derivative. I just don't want that to be gone by the wayside, when you finish up this calculus course. But I want us to really understand that the derivative is the slope of the tangent line because it's gonna haunt you until you are done with mathematics to understand that. And if it doesn't haunt you, then it's going to help you if you understand that as well too. And so let's dive right in. Let's take a look at a particular example. So it says, at what point on the graph is the slope of the tangent line equals 21? When does the slope of the tangent line equal 21 for the function y equals 2 to the t minus 3? So basically it's asking you is, hey, when does the derivative, what x value for the derivative will equal 21? That's what it's asking us in the end. Is what value for, well, it's not x, but it's t. So what value for t in this example will your derivative equal 21 when it's all said and done? So let's kind of first and foremost just let's find the derivative because we know we're going to have to find the derivative. So we talked about in our last video, we approached the derivative for a being greater than 0. So as long as a is greater than 0 and a does not equal 1, you can find the derivative of any function that looks like this and say that it is the derivative of the function itself multiplied by the natural log of that base and the derivative of whatever is the exponent that you are dealing with of the function. So let's use this to find the derivative of 2 to the t minus 3 first and foremost, okay? So finding a derivative, we want to find dt of 2, not 2t, but 2 to the t minus 3. So well, what is this going to look like here? Well, we know for sure that 2t is going to be that very first term, right? Because that is just following our formula to a t. No pun intended. So we have 2 to the t. And then we need to take the natural log of the base. Well, the natural log of the base, the base is 2 in a to the u in this case. So we need to take the natural log of 2. And then the derivative of u. Well, u in this case was just t. It was the only variable. So I didn't need to multiply by anything. Just for our particular circumstance, I'm going to multiply by 1 just because the derivative of t is 1. I just want you to understand that we are multiplying by du dx. du dx is 1. And so the derivative of t is 1, plain and simple. That's where that multiplier comes from. And then we need to take the derivative of negative 3. Well, the derivative of negative 3 is really just like minusing 0 in there as well. So that doesn't really help us out or hurt us in any way. So now, really, when it's all said and done, the derivative is 2t multiplied by the natural log of 2. So that is the derivative. And so, once again, think about what the question asked. When is the slope of the tangent line equal to 21? So basically, when is the derivative that we just found equal to 21? Well, the derivative of this going to be equal to 21 is whenever that value for t makes it equal to 21. So we need to find out what that value for t is in fact going to be when it is 21. And so let's find out here for a second exactly what it's going to be. So we are going to set our derivative equal to 21. Because that's what we want to know. And then we should solve for t. So we know in this case that 2t is equal to 21 over the natural log of 2 just by our division property. And then we need to get t by itself. Well, this is just what we've done through pre-calculus and solving for t. It doesn't go anywhere, guys. We need to take the natural log of both sides. So we natural log it because remember we can use our exponents. The natural log of 2 is equal to the natural log of all of 21 over the natural log of 2. And then we finish it off by dividing and seeing that t is equal to the natural log of 21 over the natural log of 2, all divided by the natural log of 2. Now, don't get confused here, guys. There's a lot going on. There is a lot going on in this particular problem. But just think about what we know about our properties of log. This is the property, this is the natural log of a division problem, right? So this is really just subtraction of the numerator and the denominator. So this is really just going to be the natural log of 21 minus the natural log of the natural log of 2. And that's all still divided by the natural log of 2 as well. And so now we got to this point. Why did we have to get to this point? Because this is when you can put it into your calculator, right? So at this point is when you can actually find what the natural log of 2 or the value of t is going to be, not the natural log of 2. And so when you put this into your calculator, you can roughly see that this is going to be about 4.921. So this is the value of t specifically. And so answering the question, the slope is 21 when t is 4.921. But what is y when t is 4.921? Well, y is equal to 2 to the 4.921 power minus 3, which in this case, roughly, put it in your calculator, comes out to be about 27.297. So when this is all said and done, we can go ahead and answer the question by the point can be found at 4.92 or so, or 4.9, we would round to the 10th power, or the 10th place, 4.9 and that 27 point roughly 3. And again, this is kind of an approximation that we're dealing with here, but this is our best bet that we're going to get in this particular example. So what I want you guys to do is give one a shot in which we are just finding, we went a little step above. We found a application-based problem here. I want you guys to give an example, a shot of just finding y equals 9 to the negative x. Find dy dx of this particular problem, and I will tell you right off the bat the answer is in fact going to be negative 9 to the negative x, natural log of 9. Double check and make sure you got that exact same result in there for yourself.